All right, great. Thank you, Karen. Welcome to everyone who's attending. We enjoy having you on here, and we look forward to having a good presentation today and questions throughout from you that we'll answer afterwards. And I've just got one thing before we get going here, something to help us get a feel for how many people are attending today. We're going to launch a poll, and if you wouldn't mind just giving us your response, if it's just yourself that's watching the webinar, or perhaps a group of you in a conference room. If you could take just a second and let us know how many is attending, that'll help us get a better estimate for the final count. Give you just a few more seconds. Okay, great. All right, well, thank you very much. So you should be seeing the CMF Clearinghouse website. Hopefully all of you have visited at least once, I think probably to do the registration here, but cmfclearinghouse.org. I'll be starting out with one of the most recent features we've implemented. We try to implement new features from time to time based on feedback we hear from those who use the Clearinghouse, ways to make it more useful. And so if you give me just a second, I'm going to demonstrate one of those right now. Before I get into that tool, I do want to mention, as Karen said, we're recording the webinar. We'll be posting it afterwards, and wanted to show you where you'll be able to find that. So at the top, under About the CMF Clearinghouse, there is a link for webinars. You can go there. Currently, it just has the registration for right now, for today, but after this, we'll be posting the recording and the presentation files. And then down below are the webinars we've done in past years. So if you're curious, you can go and look and see what kind of topics we've handled before, and feel free to watch through some of those. Okay. Well, this tool that I want to show you is something that we developed to try to help people as they are looking through search results, when they search for a particular countermeasure perhaps, and seeing a lot of different CMFs, and ways to help them figure out what is the most appropriate CMF for them to use in whatever scenario that they're operating in. So I'll just go ahead and start with a sample search. So perhaps I'm interested in CMFs to do with left turn lanes specifically would be what I'm going to look for here. And so in the search results, we see there's quite a few that deal with left turns of different sorts. 340, it tells you at the top. And so I'm actually going to look under the intersection geometry category, because I'm interested in a left turn lane. And under turn lanes, I can see there's quite a few to do with this here. So if I just pick one of these, let's say the countermeasure for install the left turn lane. You can see the CMFs that are presented there. There's quite a few if we scroll on down, but we can just look at the top few there. And if you're experienced with the Clearinghouse, you know that we show some summary information about each CMF. Of course, the value of the CMF, the star quality rating, the crash type and severity that it addresses, the area type where it was developed, the study it came from, and some comments. But there's a lot more, of course, to each CMF, a lot more details about where it was developed, what the sites were like, that sort of thing. I will mention, as we see here, that many times there are specific comments that we've made available for a particular CMF, and so you can see it kind of starts here, and you can click there to read more, and it'll have some special note about something about the CMF, where it's developed, its kind of site, or something that we think is germane to your use of that CMF. But just looking back here at the data that's displayed, we can see that the two top CMFs are of different values of 0.748, 0.924. Okay, so those are different. But we don't, in this summarized form, see exactly what makes them different. Why are they different values? They have the same star rating. They address the same crash type and severity. They're for all area types, not just rural or urban. And so this is something that you will encounter, is that whatever makes these two CMFs different is just not something that's displayed in this summarized form. So to handle that, we implemented a comparison tool, and it's just checkbox activated. Check the CMFs you'd like to compare. And in fact, I could compare all three of these top ones, since, again, that third one is the same as the others in the way it appears here in the summary form. So I can just check all three and hit the compare button to see how they compare side by side. So when you do that, it'll pull up a new window or a new tab in your browser, and lay out those CMFs that you checked in a vertical side-by-side fashion. So you can see across the top are the 3 CMFs that I checked. And then below that, it will list all the details about the CMFs. And so we have, as we saw on the summary page, the star rating and the crash type and crash severity, but now we have a lot more details available to us, maybe something on road division, road type, number of lanes, this kind of thing. These are the types of things you would see if you went to the particular CMF details page for each of these CMFs individually. But here we can see them side by side. And so we can look down and see where are these similar, where are they different. Okay, so they all address 2-lane roads. But there are differences in terms of the geometry of the intersections. So again, this is installing a left turn lane. And the way we've got the page configured is it'll highlight rows where things are different. So we can see that the first CMF was for 3-leg intersection, the second one for 4-leg, and the third one was based on a combined group of 3 and 4-leg. And so that's one of the things that makes these different. So if I am trying to weigh the pros and cons of the cost and the benefit of putting a left turn lane at a 4-leg intersection, if that's my scenario, I should be paying attention to that middle CMF there. Looking on down, we can see that some things are similar in terms of the study design that was used to develop these CMFs. But looking further down, we see there are also some differences in terms of the volume ranges of the sites used to develop the CMF. So you can also look at that, and we'll see another example of that a little bit later. Down below that, state of origin, they're all from North Carolina, so they're similar in that way, and they're all from the same study. I'm going to go back to the home page and just do one more, just for the sake of demonstration here. So we know that rumble strips are great interest nationwide in terms of safety improvements, lots of different kinds of implementation. And let me pull that up. So I just searched for rumble. Typically I search using as few words as possible to get a wide set of results. So I'm looking for rumble. And of course, there's a lot of CMFs to do with that. We've got 622 currently in the CMF Clearinghouse. And if we look, maybe I'm specifically interested in shoulder rumble strips, and so I can look under shoulder treatments as the category. The subcategories there you see listed, and then shoulder rumble strips is its own specific subcategory. The numbers in the parentheses, if you're not familiar, indicate how many CMFs are in that subcategory. So you can see there's quite a few. We've got 338 CMFs directly related to shoulder rumble strips. That's a pretty good stack of CMFs if you're trying to go through there and figure out what are you going to use for your cost benefit. So I wanted to take the opportunity just to point out some features we've had available for a while now, one of those being the filters on the left-hand side. So this operates similar to how you might filter your shopping results on Amazon or Lowe's or something like that. And so perhaps I'm interested in really CMFs that deal with fatal or injury crashes specifically. So I'm going to check the boxes here under crash severity and check it for fatal, serious injury, minor injury, only those, and then I'm going to click filter the results. Okay, so it'll reload the page. And now I have a smaller group of CMFs available there under shoulder rumble strips down to 147. So I've kind of narrowed that selection. And you could go through and narrow it some more if I was in a particular area type or a roadway type or something like that. But let's go ahead and look at this. So if I just pull this open here under shoulder rumble strips, and I pick this first one here, install shoulder rumble strips. We see that here are some CMFs for installing shoulder rumble strips. We can see things about the crash type. So these are for the first two are for runoff road crashes specifically. Crash severity, they address the same kinds of crash severity, fatal, serious, and minor, both for rural areas. So we have a similar kind of situation where these two CMFs, even though they're different values, 0.83 and 0.64, same star rating, they probably differ in some way, and so you might want to see that. So again, we can check boxes, hit compare, see them side by side, and yeah, even though they address the same type of crash and area, they are for very different roadway types. So the first one was for a road that's divided and is a principal arterial, other freeway and expressway. The second one was for an undivided road with 2 lanes. And so very different roadway types there. So that's definitely something you would want to be aware of as you look to see what CMF you're going to use for your scenario. you might be wondering how many you can compare. So you can check up to 6 and compare them side by side. I will also mention that there at the bottom of any search results screen that you do, that you might turn up 1, 2, 300 CMFs. You can always export those to an Excel worksheet too if you prefer to sort of work in that environment and do some filtering or sorting in that way. That's something that a lot of people find useful as well. Okay, well, I'm going to stop here and turn it over, but certainly if you've got questions, and this goes for any presentation you hear today, if you've got questions, please put them in the questions box and we'll take those and answer those at the end. So I'd like to introduce Darren McDaniel from Texas, who's going to talk to us today about using CMFs to do live saved estimates. So hold on just a second while we make Darren the presenter.
Screen. Thank you, Daniel. Can you see my screen?
Yes, we can.
Oh, very good. Thank you. My name is Darren McDaniel. I'm the Highway Safety Engineer for the Texas Department of Transportation. I appreciate the opportunity to present a recent report we've done. We've just released this year, the Solutions for Saving Lives on Texas Roads. The Solutions for Saving Lives on Texas Roads is a report of recommendations to reduce crashes and fatalities on Texas roads. And the report was a culmination of almost a year's worth of work by the Texas Traffic Safety Task Force. So the Texas Traffic Safety Task Force was formed in August of 2015 by our Texas Transportation Commission with the goal of finding solutions to save lives on the Texas roads. And the report, which is the Solutions for Saving Lives on Texas Roads, was released in June of 2016. And it provides a cost-benefit analysis on proven traffic safety improvements, and also recognizes that installing more highway safety engineering improvements and conducting driver behavior enforcement campaigns will save more lives. Of course, I'm preaching to the choir today. So let's take a look at some of the data that's presented in this report. First of all, potential inventory for highway safety engineering safety improvements is shown in the number of miles or the number of locations such as intersections, curves, or bridges. So it just takes an overall look at the inventory available in the state. The recommended portion was something we worked through for the highway safety engineering portion, and it's shown in percentage of potential inventory ranging from 10% of the bridges or to 100% of the rumble strip installation as potential inventory. The recommended portion for the driver behavior and education and enforcement is shown as the number of safety campaigns and the level of enforcement for those safety campaigns. Investment is also shown in the report. It's shown in millions of dollars over a proposed 5-year program. Of course, it could be modified to 10 years, any type of program, but for the purposes of this report, we developed it in a 5-year type program. And then potential lives saved is shown in both range of potential lives saved per year and the lives saved over the service life of the highway engineering improvement or over the 5-year education and enforcement campaign. Also, potential serious injuries and crashes prevented are shown in the report, and they range from the serious injuries or crashes prevented per year. This is what that gets. And then the estimated cumulative benefit, the part of the report that's getting a lot of attention, that's shown in billions of dollars and is over the service life of the engineering improvements or over the 5-year safety campaign and enforcement. And finally, the return on investment is expressed as a potential return for every dollar spent. We initially were looking at return on investment in percentages, kind of in the business sense, but those percentages were too high, so we expressed the return of investment as a potential return for every dollar spent. So that's the data that's shown in the report. Now to discuss the real work behind the data that's needed for the calculations. Obviously, we need the average construction cost and the quantities to calculate the investment. So it's just an average construction cost over the state in that potential quantity based on the recommended percentages to calculate the investment. We also needed crash data by crash severity, KABCO, And for those that, hopefully everybody on the call is familiar with KB, so just in case you're not, that's just the crash scale, K being fatal, A being incapacitating, B being non-incapacitating, C being possible injury, and O being property damage only. But every crash severity, the crash data is needed for that. And you need to know the number of existing crashes to be able to apply a crash modification factor. So that's why we needed to know the crash data by crash severity. And in a lot of cases, we use 3 to 5 years of crash data, and in some cases, we only need one year of crash data, depending on how much was available for the CMF. But this is where this comes in. The CMF Clearinghouse was instrumental in determining the crash modification factors by crash severity and also the confidence intervals. We used a lot of Texas data from the Highway Safety Improvement Program to determine our crash modification factors, but this report was unique in the fact that it involves return on investment and crash modification factors for all crash levels. Well, most highway safety improvement programs typically evaluate the K and A type crashes, the severe, the fatal, and the serious injury crashes. So a lot of the other data was missing for the complete report. So I will expand on the use of these CMFs and the confidence intervals as I introduce each traffic safety improvement in the future slides. But this will be the meat of the presentation. This is where the crash modification clearinghouse was essential to this report. And finally, we used the 2013 average comprehensive cost by injury severity from the National Safety Council report, which is estimating the cost of unintentional injuries. This was the latest version available. The 2013 numbers came from April 2015. So that was the latest number available at the time the calculations were made. That's key. The 2013 average, so for example, the 2013 average comprehensive cost for a death was $4,628,000. But in 2014, the National Safety Council issued the new estimated cost of unintentional injuries, and that was in March of 2016, and the average comprehensive cost for a death then was $9,887,000. So you can see it increased quite a bit there. So, but just for clarification purposes, all the numbers in this report were calculated on the latest available at the time of calculations. So you can see this is a conservative estimate of the return on investment, but you can see what it would do if you simply just updated it with the new National Safety Council numbers. So to get into the individuals, Daniel just did a demonstration on rumble strips, and this is probably our most popular item. But rumble strips, Texas has had a rumble strip policy on rural divided highways since 1999. So we've had edgeline rumble strips for quite some time in this state. So what this program does is it expands that program to rural undivided highways and includes edgeline and centerline rumble strips. So we had a lot of data available on rumble strips, so we had very tight confidence intervals. And we were actually able to develop unique crash modification factors for each crash severity. So a lot of confidence in our rumble strip data. The second was urban intersection improvements. Now, this one varied a little more. Texas had an intersection safety implementation plan that we worked with the FHWA that determined that urban signalized intersections had the highest risk factors. So our focus became urban signalized intersections, and it didn't really matter whether it was on system or off system. That was the focus of the study. But typical intersection improvements for this case are ranging up to $50,000 per intersection. So these aren't major improvements. What it is essentially improving signal awareness, such as advanced warning signs, additional signal heads, and additional pavement markings. So we're not talking about complete redesigns of these intersections. We're talking about $50,000 per intersection. Each signal is unique, so the CMF varied more because some signals may need additional items, some may need less. So we use the CMF Clearinghouse extensively to develop the range of CMFs and all the possible improvements. And we applied the same CMF range which was 7 to 15% to all the severity levels. So a lot more variability in this. Now you may notice that the potential lives saved is a little lower in this category than the other safety improvements, but the cumulative benefit is still very high. And the reason for that, we found, was that only 10% of the serious crashes at urban intersections resulted in a fatality. There were a lot more serious injuries. And the reason for this may be because these intersections are typically located in urban areas, and the emergency response time may be quicker than some of the safety improvements in rural areas where the emergency response time is longer. So same type of crash, different type of response. The high friction surface treatment on curves, we targeted curves with a wet weather crash ratio higher than the statewide average. And we identified up to 1,000 curves with this wet weather ratio higher than the statewide average. And so for this purpose, we used a wet weather crash modification factor for the high friction surface treatment. Next is concrete and cable median barriers on divided highways. Now we specifically use CMFs from the CMF Clearinghouse on this one because, like I said, in the Highway Safety Improvement Program, we were tracking fatal and serious crashes, and concrete and cable median barriers do an excellent job of reducing fatal and serious injuries. But what we learned from the Crash Modification Clearinghouse is that we liked is that it included all collision types. In fact, we even noted an increase in PDO crashes due to the added presence of a fixed object. So our crash modification factor, we actually use crash reduction factors, was actually negative in that case for property damage only crashes. But it was very good data to have. Modernizing rail and approach guardrail. This was a unique item in the fact that it will not reduce crashes. Obviously, the guardrail is already there, and if you hit it, it's still going to be a crash. So the only thing that this is doing is improving, improving the guardrail doesn't reduce crashes. Instead of a crash reduction, we used a 15% in severity. So the severity, the crash is still going to occur, but the severity would not be as much due to an improved guardrail. Hopefully that makes a little sense. And our last highway safety engineering improvement was widening highways and narrow bridges. And we actually, through our study through the crash modification factors and whatnot, we actually modified this to include widening narrow highways, bridges, and adding rumble strips. So this includes widening rural highways less than 24 foot wide to 26 foot wide, and adding edge line and center line rumble strips. And so the unique aspect of this is that the CMFs assume that the highway widening and rumble strips are independent, which is consistent with the current highway safety manual. So that was a unique aspect of this one. Next, I want to be talking about, we have one more highway safety engineering item, and that is traffic management system improvements. And a lot of this was done by a report from BCG, so I didn't have a lot of the background information on the CMS on this, but we used, you can see the tremendous benefit from improving the traffic management systems, adding DMS, adding CCTV, and whatnot to the existing traffic management system. A lot of folks are referring to it as TISMO now. So next, I'd like to talk about driver behavior and enforcement. Now, a lot of this does not come from the Crash Modification Clearinghouse because this is more on the behavioral and education aspect, but we did have some useful information to relay here. The first one was our safety belt campaign and enforcement. Like a lot of states, we have a click it or ticket campaign that typically runs 1 month a year. And so we examined the possibility of running a year-round click it or ticket campaign along with the strategic traffic enforcement program, the STEP enforcement. So the National Highway Traffic Safety Administration has a calculation that can calculate, based upon your seatbelt usage, lives saved. So we used a lot of the NHTSA data for this. And we had a minimum, a median, and a maximum on this. You can see the range. The minimum was based on Washington State. Washington State has a very successful safety belt campaign, and so if we were to see results similar to the state of Washington, we used our safety belt usage for that. That was our minimum numbers. The state of California also has a very successful safety belt program, and that, in fact, it's a little more aggressive. And so we used our median numbers. If Texans responded as Californians did to their safety belt program, and our usage went up, what would the lives saved be? And then lastly, our assumption was if we just do a year-round click it or ticket campaign, could we immediately achieve a 95% usage, seatbelt usage? Currently, when the report was published, our current seatbelt usage was 90.47, and our recent numbers, it's already to 91.6. So that's based just on the baseline. That is our safety belt campaign and enforcement. Second of all, our impaired driving campaign and enforcement. We actually found a meta-analysis study that had a really good demonstration of the effectiveness of safety campaigns with enforcement, and it stressed that enforcement was key on that. And so for alcohol-related enforcement, we found an average of 4.9% effectiveness based on the program. So this impaired driving campaign enforcement includes an additional drink drive go to jail campaign that goes along with the drive sober or get pulled over campaign. It also includes safe ride vouchers for a lot of the ride service companies, and providing some type of voucher to encourage that free ride home for somebody that's been drinking. Also, a new traffic safety campaign and enforcement, which includes distracted driving, speed-related, work zone-related, and pedestrian safety traffic safety campaigns, along with step enforcement. And so we found some interesting facts on this. Distracted driving, we felt like we can get a 3% reduction. Speeding, not as much, only 1.1%. Work zone, 3%. So. Also, we have an expanded motorcycle safety campaign and enforcement. Texas is a state that does not have a helmet law, but we do have the highest helmet usage for a state without a helmet usage law. So we're very proud of that, but we know we can improve that. So we had 3 safety campaigns for this one. Look twice for motorcycles to increase awareness for motorists of motorcyclists on the highway. Helmet safety campaign, and also an impaired motorcycle riding campaign, along with step enforcement. And we found that we felt like we could get about a 4.9% reduction in this area for motorcycles. And our last campaign I was going to talk about today is the Texas High School Traffic Safety Campaign. This is the only safety campaign we did not have with the increased enforcement. But we found we could get about a 3% reduction for this safety campaign for that. And it's a Texas High School Football Friday Night Light campaign. It's the Texas High School Project Graduation campaign, increasing that. We also have a program through Texas A&M Transportation Institute, the teens in the driver's seats, and then just a typical Texas High School campaign for Pampas. But you can see the potential return for investment is very high on that as well. So adding all that up, it's a mere investment of $2.7 billion. But if you look at the potential lives saved, 2,735 potential lives saved, and the cumulative benefit of $32.4 billion, you're looking at more than 540 lives that could be saved and thousands of crashes prevented each year at an average annual investment of $540 million, which is a 12-to-1, $12 benefit for every dollar spent on these safety strategies. Now, I know we're going to save questions to the end. but I've added a link here for anybody that's interested in seeing the report in full. So thank you for your time.
Great, thanks, Darren. I appreciate you walking us through that. And I assume when you plop this report down for the legislature, they wrote you the check for the $2.7 billion. So, but it's a good example of using good data, good safety data. You had a lot of data underwriting this thing, you know, CMFs and everything else included. Really nice example of using that to show the potential benefit of a lot of different types of safety improvements. So thanks for bringing that to us.
Thank you.
All right. Well, we're going to hear from Tracy Turpin now from Virginia. Who's going to talk about doing benefit cost analysis, specifically with an aspect on systemic safety improvements. So Tracy, we're turning things over to you now. So you should be getting screen control. Yep, we see your screen there, and you should be able to talk live now.
Hi, thank you. Congratulations. Good afternoon, everyone. I'm going to speak a little bit about VDOT's HSIP program. Basically, here in Virginia, like all states, the VDOT HSIP is coordinated with the Strategic Highway Safety Plan, meaning that every project that's programmed in VDOT HSIP has to be related to our Strategic Highway Safety Plan, one of its emphasis areas. In Virginia, we have two of our main emphasis areas are roadway departure and intersection crashes are two of the main emphasis areas that Virginia has to focus on. And so we're going to talk a little bit about how Virginia is trying to approach systemic improvements addressing those two areas. One is that you know that in Virginia, like all HSIP programs, we're data-driven. We're using a data-driven approach to identify our crash locations using a severe network screening process that we developed here in-house in Virginia. And with that, we use those to help us fund those projects that we can address those crashes and systemic risk factors on any public roads in the Commonwealth. Like I said, VDOT HSIP program is basically, like I said, purpose is to be relevant to the program purpose of reducing severe crashes or risk to the transportation users, and that's all transportation users in Virginia. We have a robust HSIP program here that I want to talk a little bit about later on. Part of the things that we do is we address hazardous situations through good safety planning. Like I said, it's a data-driven process. With we use highway safety manual methodology for our network screening process. One of the things we do with our HSIP projects, though, is that they have to comply with the VDOT design guidelines and standards, although the sole purpose is not to bring these projects up to design standards. Okay, the purpose is to mitigate safety and address those severe crash locations that we've deemed unusually high in the severity and rate of crashes that occur in those vicinities. And lastly, we upgrade the non-standard safety features to existing standards if they're related to the target crashes, or they fall within the work area of the engineering study or been identified in our roadway safety audits or RSAs that are conducted on the safety projects. Okay. Like I said, HSIP funds are available, like I said, for two types of projects. One are locational corridors where no substantive safety problem exists, or locations where a risk-based analysis has demonstrated the need for low-cost or widely implemented systemic countermeasures that target high-risk roadways. Part of the HSIP program is that VDOT has developed a highway safety improvement implementation guide that's located on our Virginia DOT external website. I welcome anyone to go out and take a view of the implementation guide. It addresses how VDOT deals with the HSIP program, the systemic improvements, and actually all four components of the highway safety improvement here at Virginia. The HSIP implementation process involves, like I said, the identification of high-risk locations as well as the analysis of problems and countermeasures that have been addressed on the Commonwealth of Virginia highways. And lastly, but the prioritization and scheduling of the improvement projects. As you'll see, we're going to get into the example of the form. We'll see where we identify how projects are prioritized and how the schedule is important to the important to the delivery of the safety program here in Virginia. Virginia HSIP program consists of 4 elements, or 4 components. Basically, we had the highway safety program, which is the HSIP, which is a benefit cost-driven process that we have application form for. Then we had the bicycle and pedestrian safety program. That's a risk reduction application that we've developed that addresses bicycle and pedestrian accommodations throughout the Commonwealth, as well as the highway rail grade crossing safety programs managed under the highway safety program here in Virginia. And lastly, we have what we call the local agency safety program or the local administrative safety program, which basically be the benefit cost risk analysis for the highway safety or for bike and pedestrian safety projects. The local agency safety program is the program that allows local municipalities to manage the safety programs in Virginia. As you know, Virginia maintains a vast majority of its highways and roadways in the Commonwealth, but we do have localities that do maintain their own road systems, and this program allows them the flexibility of managing that program. Under the highway safety program, well, there are 2 traditional types of projects that we are talking about. Under the HSIP, you had the HSP traditional benefit cost ratio or spot location applications that we have received, and we also have what we call the systemic projects, which are basically low-cost, multi-location countermeasures that we can use widespread around the Commonwealth. In VDOT, traditionally, we've so far been able to spend about 30% of our funds on systemic type of projects and about 7% of our funds on traditional spot location applications. With the adoption of MAP 21, the systemic approach institutionalized a new methodology for Virginia traffic engineers to deploy. VDOT districts and our local agencies determine a balanced approach between the 2 safety approaches. And like I said, HSIP initially said target allowing for 1/3 systemic and 2/3 without traditional local projects. However, VDOT has made a commitment to fund as many systemic projects as possible. So, and one of the challenges that we had is finding good systemic projects to improve in the safety program. And as you can see by the 2 maps to the side, the difference between systemic, you see the group of little red dots versus the traditional spot locations. That with systemic, we can touch a lot more areas or localities with systemic approach than just doing the traditional approach on projects. For our systemic HSIP application process, VDOT adopted the FHWA 9-step approach to implement systemic projects. As you can see, from step 1, we determined the focus or crash or facility type of, and that's basically could be a focus crash type, could be an angle or rear end type of crash, or a facility type could be a signalized or unsignalized intersection or curve or a tangent. Step 2, we address the analyzed risk factors, which determines the most predominant risk elements or risk factors associated with those focus crash types or focus facility types. And then for selection 3, or the 3rd step in the process, is that we identify and select countermeasures to address those type of crashes that we had identified in the risk factor section 2. Steps 4 through 8 are determining the number of locations that can be appropriately addressed during this process. And that would be determined by the number of locations that meet a threshold or the available budget that's available to deliver this program. And then finally, step 9 is determining the targeted KV crashes that we'll be addressing during this improvement or during the systemic process. I'll go through the process a little bit more in detail when I get into the tool and working through the spreadsheet of the systemic approach tool. Okay, and we'll get to the example of that. Right here is a full example of the systemic approach tool, systemic application tool. The systemic application tool is basically broken into 3 steps or 3 parts of the application process. The first step is the same for whether it's systemic or traditional application. It's just that we ask for general project information from every applicant that applies for safety funding in Virginia. And that is that we're asking for the agency, a locality that's sponsoring this project, the project sponsor, and that's the person who can be held accountable for the delivery of the project. With that person, we need your contact information, so if there's any questions about your application or about the status of your project, we can have readily accessibility to you. Again, we talk about whether it's a priority or whether you have, and basically if you have more than one application for a location, we ask that you identify your priority level, which one of these applications has the top priority for you, because sometimes with limited funding, we're not able to address all of your projects or all your requests, so we need to know what would be the priority of the urgency of this project there. Along with, we ask for the location and a brief description of the project that's going to be addressed. So, we actually, if you can identify the type of project that you're applying for and what kind of results that you're looking for with this project. Okay. Part 2 of the application is what is different from the traditional application. This is the systemic application process where we ask for your focus crash type and your focus facility type. In order to determine either the focus crash type or the facility type, we analyze the crash data to determine which crash type of facilities are the most predominant in that district or that locality. And then we indicate the focus crash type and facility type through drop-down menus off of the application bar. As you see in the far left where it says focus crash type, that can be addressed either be roadway departure, angle crashes, rear-end, sideswipe, head-on, bicycle, pedestrian. Those would be the focus crash types that we could be addressing with this type of application. As well as focus facility type, we can look at whether it be on a curb or signalized or unsignalized intersection or things of nature like that. So those would be some examples that we would look at when we're filling out the application, when we're asking for a crash type and facility type. An example of that could be that one of our VDOT districts may find that they have a high proportion of roadway departure crashes, and that those crashes occur on curves or tangents. But the most severe crashes occur on curves, so therefore the focus facility type would be a curve, and the focus crash type would be a roadway departure that we address. Okay. Or another example may be that a district may find that the majority of crashes occur at intersections, and that the crash data is a primary angle and rear-end crash types. But however, the angle crashes have the more severe crash. So again, we'll focus on the crash type as the rear end because they had the more severity crash, but we also focus on the facility type as the intersection because of the focus crash type and the focus facility type. So that's an example of how those features are utilized in that. Okay. The next part of it is the proposed systemic improvements. Okay. Basically, the applicant will select from drop-down menus the type of systemic improvements that we address based off the focus crash type and the focus facility type that's been identified. Again, we made these drop-down menus so that we're trying to keep we try to keep the applications as straightforward and direct as possible, and we want to be as consistent with the wording and the description type as possible so that when we go to evaluate this, it won't be trying to spend time determining what the applicant meant when they wanted a particular type of improvement. So we identified certain canned drop-down systemic improvements that are associated with the focus type and the crash type. Okay. The number of locations that would be treated is based off is a three-step process. I mean, the first step is that the applicant would determine the number of locations that they want to address with the systemic improvement. There could be anywhere from 5 to 20 to 25 to 100 locations, how many locations that the applicant feel that they want to address with that. The second part is, though, is that those locations meeting the threshold to justify for systemic improvements. And those thresholds were predetermined by VDOT staff and some input from consultants around the state who have looked at similar projects in similar locations around the state and country to determine what the threshold would be for those type of improvements or those type of crashes that occurred at those locations. And the third thing would be to determine the deployment level. The deployment level is that, well, and that's based on the funding that's available to the localities. Because if you have in this example, we had total of 20 locations, but only 10 of those locations meet the threshold of 12 crashes in 5 years. And with a deployment level of 50%, therefore, the number of systemic improvements that could be deployed is 5 for for the amount of funding available for that particular location or that countermeasure. With this allows us to know that we can put in the total number of locations, but we give some guidance based on the threshold and the deployment level, will tell us exactly how far our dollars can spend on a safety improvement or a countermeasure. And then we looked at targeted KAB crashes over this. So to address, the last thing is to address the KAB, as Darren said earlier, that Virginia also used the KAB-CL scale for crash severity out of CMF. So we address the targeted KABs with this systemic approach. And then from there, we go to the last part, or the last part of the application of this tool is to calculate the benefit-cost ratio. Okay. In order to calculate the BC ratio, the applicant must enter the appropriate CMFs from the clearinghouse for the countermeasure selected. Okay. And again, there are currently 3 spots of CMFs for each proposed systemic improvements to determine the focus of the systemic problem. Okay. The CMFs should be for the fatal severe crashes, as they were determined to be the focus of the systemic program. And if all 3 apply to the same type, then only one should be marked yes for inclusion analysis. That means that we can have up to 3 CMFs identified for a systemic improvement program. Virginia, we only applying 3 CMFs on a particular project at a time. Okay, and the thing is that if all the CMFs are addressing the same type of problem, then only one should be checked to be used as included in your benefit cost analysis. Okay. If you have multiple CMFs that are addressing different type of crashes, then you check all 3 of those CMFs to be included in the calculation of the benefit cost analysis. But like I said, in Virginia, though, we have a maximum, as recommended by the clearinghouse, that no more than 3 CMFs be combined at one time. Again, as noted in the CMF Clearinghouse, the common practice is to multiply CMFs when multiple countermeasures are implemented at one location. Again, it is unlikely to have the full effect of each countermeasure would be realized, and unless the countermeasures act completely independent, multiplying several CMFs is likely to overestimate the combined effect. Therefore, unless the countermeasures act completely independent, we should caution that engineering judgment should be exercised when especially estimating the combined effect of more than 3 countermeasures at any given location. As you see, and this is all based off the clearinghouse CMF. But like I said, again, as noted, in Virginia, we are only multiplying maximum of 3 CMFs at one time, and that gives you a combined benefit cost ratio of your systemic improvement project like that. Okay, so again, this is a brief overrun of the application tool. It's a really straightforward process. This year is something new in Virginia, and I didn't include this in the slide, but we've used what we call a smart portal tool. So anybody who's, all applicants go through an online smart portal tool to download this application, fill this application out online, and it's submitted to us electronically. And with this process, it has a alert button on it that allows us to communicate back and forth with the applicant. If there are things that are flagged on the application that is not complete, or we look at the application and see that there are areas there for improvement, we have the ability to communicate directly back with the applicant without any transferred or paper files or emails. It's all done through a smart portal tool that we have here at VDOT that's allowed for the download, the print off, and to review your application before it's submitted for final processing. And with that, that's the end of my presentation. Thank you.
All right. Great. Well, thank you, Tracy, for walking us through that. And again, I'll say for anyone out there who has questions, either for Darren or for Tracy, go ahead and pop them into the question box. And it actually would kind of help if you said for Darren or for Tracy if you've got something specific for one of them to answer. All right. Well, Moving on to our final presentation here, sort of full circle. So back to Karen, who's going to talk to us about state CMF lists.
Great, thank you, Daniel. So over the past couple of years, Federal Highway has been encouraging states to develop state CMF lists. Many states, or I should say some states, have had a state CMF list for many years, and we've seen more and more states following along the same path and developing state CMF lists and guidance for other entities within the State Department of Transportation as well as other agencies to use in applying CMFs. And so we've been working on a flyer to help and encourage states to develop a state-specific CMF list, and we're putting the finishing touches on that flyer, and with any luck we'll be able to share that with you when we post the recording of today's webinar and the slides to the CMF Clearinghouse website. But while we're doing that, I wanted to share some of this information with you here today, just to take a few minutes to do that. So when we use the term state CMF list, we're referring to a list of pre-selected CMFs that's adopted by a state for use on all safety projects in that state. What we've seen from some of the other states that have developed state CMF lists is that these lists can come in all shapes and sizes. They can be a short list of commonly used CMFs. They can be a longer, more comprehensive list that includes additional information about countermeasures. But the bottom line is that the state can determine the type of list that best suits their needs. But it would be helpful for all states to have a state CMF list for multiple reasons, and I'll just talk through a couple here. But having a state CMF list ensures consistency in the application of CMFs across the state. So a state CMF list would require all agencies or entities within the state to use the same CMF for use on safety projects, and that would make the project selection process consistent and fair. So if all states are using the same CMF to estimate the benefits of a particular countermeasure, then there would be a consistent process in place for that. I don't know if any of you have seen the most recent edition of our CMF update, which is the e-newsletter for the CMF Clearinghouse, but it was surprising to me to see that we are now over 5,000 CMFs in the Clearinghouse, and to someone that's not familiar with CMFs, that could probably be a little overwhelming. It's probably overwhelming even for those of us that use CMFs on a pretty regular basis. And so by having a state CMF list that leverages the experience of those folks that have more expertise with CMFs and using that expertise to select the best CMFs for use in a particular state, and providing that information to those that may have less experience with the application of CMFs. The state CMF list can also be helpful to improve communication between public officials within a state for particular reasons for using certain countermeasures, especially those that are relatively new to the state. So it could help to demonstrate the benefits or value of using one countermeasure over another. So who develops a state CMF list? I would argue that any state can and should develop a CMF list. And what we've seen from some of the states that have developed CMF lists is that they're commonly developed by a committee of experts within the state that have experience using or developing CMFs. And these experts have a range of responsibilities, focus areas, and agency affiliations. So it might include state safety engineers, design engineers, the folks that will actually be using the CMF, so district staff or local agency staff, and then sometimes the federal division staff who approve the projects that are generated through the use of those CMFs are involved in that expert committee. So the flyer that we're pulling together includes some considerations when developing a state CMF list. So these are just some of the things you might want to think through if you do decide to pursue the development of a state CMF list. And some of those considerations include what resources will you use to identify potential CMFs, for your state list. Some states use only those CMFs that are in the Highway Safety Manual. Other states might use CMFs from the Clearinghouse, but only those that have a 3-star rating or better. You might also consider what aspects of the CMFs will be important in the selection process. So will you be looking at roadway class, area type, the state of origin for a particular CMF? You might also think about how you might select CMFs when there are similar CMFs for a particular countermeasure. Will you select the one that's most appropriate for your state? Will you combine values from multiple CMFs or use some other method? One problem you might run into is what if there is no CMF for a particular countermeasure of interest? And what we've heard from other states is that sometimes they'll base a CMF estimate on past experience, maybe from simple before-after analysis from previously implemented projects. They might use expert judgment and assume a CMF based on CMFs for similar countermeasures. You might also consider what information should be included on the state CMF list. Would this include a description of the countermeasure? Would it include a specific CMF or maybe a range of CMFs? And specifics about the roadway characteristics for which the CMF applies. There is a wide range of information that you could use. Sometimes it might be in tabular format. I've seen some states have this in a more descriptive type format. And then the last thing you might consider, and I'm sure there are more than we have listed here, but is how often you'll update that CMF list. Maybe you'll do that on a quarterly basis as we update the CMF Clearinghouse's new CMFs, or maybe you'll do it on an annual basis as you update your HSIP application process or similar. And so I also wanted to point out that you can certainly learn from others who have been down this path already. We have a sample of state CMF lists on the Clearinghouse website. We have lists from 8 states available on the website, and I know there are other states that are not listed here that do have similar type lists or state-specific CMF lists. And so if those states would like us to link to or provide those lists on our website, you can let Daniel or I know, and we can include them on the website. So if anyone from your state is on the Clearinghouse website and looking for what CMS they should use in your particular state, they have that information there and available to them. With that, I'll wrap up here and turn it over to Daniel in just a minute. I did want to mention, though, that our intent here is to help anyone who is willing and interested in developing a state CMF list by providing some information to guide them through that process. If you think this is something your state would like to consider, but you don't know where to start or need help thinking through this process, please let me know. We are happy to help you do that. And so with that, I'll go ahead and turn it over to Daniel so that we can answer some of your questions here today.
All right, great. Thank you, Karen. We'll take screen control back over here and just have the website up. Wanted to mention also, so Karen showed a list of states that have these state CMF lists, the ones that we've got listed on the Clearinghouse and have linked to their state page, or just have the list right there on the Clearinghouse. If your state has a list and we don't have you listed, please let us know. We'd love to make that available so that others can see what's on there, make use of that knowledge. So please let us know if that's the case. All right, well, we're going to go through some questions that have been submitted from various folks during the webinar. We've got some pretty good amount of time to work with, so we're not under pressure there. And we'll be, just for the presenters, I'll just note that we're going to be unmuting all of you so that you can respond to the questions that come up here. So question here for Darren, for what you talked about out of Texas. Somebody was interested to know if you were using any CMFs that were developed in-house for some of the treatments that you were addressing in that report. So we know that you mentioned using CMFs out of the Clearinghouse. Did you have any that were developed just in-house right there in Texas?
Yeah, absolutely. As you saw on the list, our CMFs are listed on the and they're listed as crash reduction factors, which is easily reconciled, but they're listed on the website there for the CMF Clearinghouse. But yes, we did use a lot of in-house data, especially for rumble strips and widening highways and whatnot, where we have a lot of experience and a lot of before and after data. The CMF Clearinghouse was very useful in the data like the high friction surface treatment, where we didn't have as much in-state data. So.
Great. All right, great, thanks. And yeah, it was. I appreciate hearing, Darren, how y'all use the clearinghouse for that. We kind of joked with Darren that even though this is just talking in general about using CMFs in this kind of analysis, we appreciate the name drops throughout the presentation. So I think, Darren, you might have had more name drops of the CMF Clearinghouse than Tracy, but Tracy had a screenshot, so I think that might, I don't know, he might outweigh that one. So a question for Tracy. There was someone asking about when you were identifying the systemic projects. Of course, for intersections, it's pretty clear when you're talking about a site location, just that specific intersection. But someone's interested in knowing when you're selecting sections for systemic treatments, what is generally the length of the section that you're talking about when you talk about a site? A section, like how long is that generally speaking?
It varies quite a bit here in Virginia. I mean, normally we try, when segments get sketchy, because then you can get to the process where you're doing a corridor analysis or you're doing a segment analysis. So it depends on the type of improvement that they're trying to implement and the number of locations that we're actually addressing with that. Like I said, again, anything get to the extent of anything over a mile long or whatever like that, you can pretty much address that as a corridor analysis versus a segment. But it's very specific on the countermeasures that's being implemented and the number of locations that have been identified with that.
I'd like to actually follow up that. Tracy, you talked a lot about the systemic improvements, had a couple examples. I was just curious to know what are some of the more prevalent systemic improvements that you see being used there in Virginia?
Okay. We have a few that we're doing, particularly, like say, the reflectified backplates for several locations in locality. The flashing yellow arrows are another one that we implement. We also try to use the oversized chevrons for curve warning on secondary routes in the Commonwealth. So those are the type of the systemic improvements that we're trying to address.
Gotcha. All right, great. Just looking at the questions here. It's actually, Tracy, you're on the spot. There's another one here for you. So you talked about the fact that Virginia, you don't, in this benefit cost analysis, you're not using more than 3 CMFs. You're kind of following that that rule of thumb, if you will, that you're not going to, kind of involve more than 3 CMFs when you're trying to estimate the benefit of a project. And someone just wanted to know a little bit more about the logic behind that.
Yeah. What we found is when you start combining more than 3 CMFs to one application or one improvement type, the benefit tends to be overestimated, and the actual benefit of the CMFs go down. So we found that 3 or less CMFs at one particular countermeasure improvement type is about the maximum benefit you're going to get from that type of improvement.
So it's yeah, go ahead, Darren.
I agree with Tracy on that. Texas does that as well. We allow projects that have obviously more than 3 types of safety improvements. Some will have up to 7 or 8 safety improvements, but when trying to calculate a safety improvement in a benefit cost ratio, we do limit it to 3 as well.
Right. So you're both. Yeah, I noticed that you're both kind of addressing that, Darren. You had one specific on that, and so it's kind of a cautious approach. You're trying not to overestimate what might be the benefit of doing all these different types of safety treatments. You can't assume that you get the full effect of each one of those because they do the same kinds of crashes. Yeah. And there
by choosing the 3 main types, you're getting a good picture of it. So.
Absolutely.
Right, and that there is some language in the Highway Safety Manual to do with the magic number 3 there. It's been kind of the rule of thumb for a while now, and just kind of trying not to overestimate. Great. The question has been submitted, kind of maybe open to everyone here, but basically is bringing up the point that I think as Darren you had recognized in some cases, there are CMFs greater than 1. And so what that means, just to kind of translate that, is if you see a CMF greater than 1, that's indicating an increase in crashes. And I know, Darren, you mentioned that with the hard barriers, the concrete barriers that you see, the CMFs over 1 for, the lesser severity crashes because you're getting more crashes, people more, hitting the barrier more. Of course, you're also at the same time preventing those very serious cross-median, crossover and head-on crashes.
Correct.
And so the question is, should CMFs greater than 1 still be considered, or if a treatment or a countermeasure has a CMF greater than 1, should it still be considered a treatment for consideration? And I think, Darren, your example was a pretty good one of that you might have a countermeasure where you've got a CMF for maybe one severity type, or one crash type that is over 1, but you want to look at the full picture, right? You were also looking at, but what other effects are you seeing? And I imagine you might see that in some other cases.
Well, traffic signals are a great example of that. Anytime you install a traffic signal, your crashes, your property damage, only your rear end type crashes are typically going to go up, but your severe cross angle crashes are going to go down. So yeah.
Yep. Great. Let's see. Just looking through the other questions that were submitted here. And a couple just sort of about finding, I think really kind of addressing the finding of CMFs and what we've got on the clearinghouse. Someone is asking about, for a little elaboration about the star rating, so that some of you may not be as familiar with the star rating that's used on the CMF clearinghouse, and that showed up when I was doing some of those demonstrations of searches. So we use a 5-star rating system here to indicate the quality or the reliability of the CMF, and so this is not to do with how effective the treatment is, but rather the number that's indicated by the CMF. How much confidence do we have in that? Is that based on a well-done study using a large sample size, or is it based on just a very small study, just a few sites, and doesn't have a lot of reliability behind it? So that's what we're getting at with the star quality rating. And I'll mention here, I'm kind of hovering over the text, but on the Clearinghouse website, if you go to About the Clearinghouse, there is a page where we describe the star quality rating, so I'll let you look at that, but you can see the criteria that we use and kind of what plays into that rating scale. And while I've got that up, someone else was asking a question that is somewhat specific to IHSDM, but I think it's good to bring up here. So this person is saying that the Interactive Highway Safety Design module doesn't have CMF analysis for 4-way stop control. So 4-way stop or all-way stop. And this person's recognizing that a lot of rural intersections use this type of control, and they're wondering when or if CMFs will be developed for this type of control and included in the future software versions of IHSDM. So I can't speak to IHSDM, but I can, in just a short fashion, show you, and it's maybe just a good demonstration of how would we look on the clearinghouse for CMFs to do with this specific countermeasure of 4-way stop or all-way stop. So as I mentioned before, I typically, when I'm searching, try to use maybe more general words and as few as possible. I want to get a good wide set of search results so I can trim that down later. So I could, maybe if I know that I'm going to call this all-way stop, I might just search for all-way. That might yield me something. And so it does, 27 CMFs under these two categories of intersection geometry and traffic control. So if I drill down inside those, I can see that there are here countermeasures dealing with converting minor road stop control to all-way stop control. So I think that's sort of along the lines of what this person might be interested in looking at. So that's kind of a demonstration that we have the CMFs in the clearinghouse arranged and categorized by the countermeasure that's being addressed here. So for instance, you're converting a minor road stop or a 2-way stop to an all-way or 4-way stop control. So that's an example of how you could look for that. If you wanted to even be more general, you could just search for stop, perhaps, and that would get a lot of different CMFs that dealing with stop controlled intersections and this kind of thing, anything to do with changing stop control. And there's a lot more that come up with that kind of more general word, 242. But again, I can just still drill down inside the same categories, down inside traffic control type, and I can see a lot to do with and some that deal with other things like converting stop control to yield control. So I just wanted to kind of highlight that as just a little demonstration of how to use the CMF Clearinghouse to look for specific countermeasures. Let's see. All right, if anybody has any extra questions, feel free to submit it. I think there's a few left here that we might try to touch on. So there's a question related to, is it a good idea to develop a CMF list? I was just kind of getting carried, what you were talking about, CMF list for a region that includes several states. So, Karen, you were talking about, these lists that were developed just within states. And it would be a good idea for a group of states, some kind of, region-wide list. And I don't think I've seen that kind of thing. I think maybe certain, I don't know if maybe MPOs might be looking at that sort of thing or using those. And I don't know, Karen, if you running across something like that.
I've not seen that either, but that's not to say that it can't be done, especially if the states are very similar in terms of geography and terrain and those sorts of things.
Sure, absolutely, yeah. A lot of, if you got several, Midwest states or something that would have a lot of similarities in terms of those kinds of things, topography and that, it can make a lot of sense. I think some of the motivating factors behind doing the state CMF list may be particular to states because a lot of it has to do with project funding and, sort of competing for project funding on various types of improvements. So that may be why it's typically more at the state level. We've got a question here related to if there's a CMF in the CMF Clearinghouse, and there's also CMFs on that same kind of measure in the Highway Safety Manual. How do you compare those? So if you've got some CMF coming out of the Highway Safety Manual for a particular treatment, but then you see other ones in the CMF Clearinghouse, how do you choose? I think is what it's kind of getting at. Which one takes precedence? And this one is. It's a multifaceted question. Certainly there are considerations about the quality. You want to look at the star quality rating and see is the one that was listed in the Highway Safety Manual perhaps of the highest quality that you might find here, and that could be a big factor in when deciding whether to use it. But there are also other considerations that I would encourage you to look at. For instance, if there are CMFs in the clearinghouse that maybe are more specific to your scenario or to your state or something that makes it maybe more tailored to the kind of situation you're in, that might be a reason to look and see if there's a CMF that is maybe not in the Highway Safety Manual but might be more specific to what you were looking at. I'll mention that if you do go in here, you'll see, in fact, I can keep this up as an example. CMFs that come up in any search results, if they have this little letter in brackets here, so we see a B, and an I, that's an indication that that CMF is in the Highway Safety Manual, the first edition, and that the letter actually indicates how it was displayed. So those first two were displayed with a bold indication. That third one with an italics indicates something about the quality. But that's how you can see whether the CMFs are actually in the Highway Safety Manual. So I think this person's recognizing that there are other ones. If we keep scrolling down, there are other ones here that aren't. And so it's a very good question. I encourage you to look a lot about the details of the CMF. If you click on the CMF value, you'll get taken to a page where you can see all the details about the CMF, where it was developed, and that sort of thing. So I definitely encourage you to take a look at that.
Daniel, I'll also just mention that the CMFs that are included in the Highway Safety Manual are the best available CMFs at the time of publication, but that was in 2010. So it may be that there may be a better CMF now since we've added 6 to 8 years of new knowledge to the clearinghouse. So like Daniel's saying, I would just encourage you to look at the studies and make the decision based on your circumstances.
Yeah, that's a great point. Darren and Tracy, I'd be curious to hear any thoughts you have on this. As you go through the clearinghouse, and you mentioned you were using that for a lot of the basis of your CMFs that you're using. Darren in the analysis that was done there, or Tracy and the systemic, estimated systemic benefits. Do you face this situation where you're trying to weigh between CMFs, what to use, and how do you handle that?
I think Karen brings up a good point. It's just it could be in the CMF Clearinghouse, just more updated and whatnot. Ours are more typically we really like the new filter feature to pinpoint whether you're in rural or urban or the type of severity you're looking for. So a lot of our focus has been on the top level, the K and the A, the fatal and serious injury crashes.
Yeah, and we do a similar here in Virginia as well, Daniel. You know, we are, Virginia, we look at CMFs in the clearinghouse that have 4-star rating or higher. Anything less than a 4-star, we don't really try to implement. So we look at that, and we use the star rating to help us determine a lot of our CMF selection. But I agree, you know, we recognize that the highway safety manual is a little dated with some information, so we rely more on the clearinghouse as far as our CMF selection.
Great. Yeah, that's yeah, certainly all the CMFs that were in the first edition HSM are in the clearinghouse with those indications I showed. But Karen is right. There's been a lot of good safety research coming out in the years since then, and it could be that there's been perhaps a larger study, one that had more opportunity, have a larger sample, maybe better funding, and I think you might see that reflected in the second edition HSM to have these newer and updated CMFs. Okay, great. Well, I just want to say thank you to Karen, Darren, Tracy. Thank you for your sharing what expertise and you know, the experiences you've had using CMFs. Very much appreciate that, and thank you to all of you for attending. I just wanted to mention a few things here at the end. You'll get an email tomorrow following the webinar, and it will have in there a couple things. One that will certainly interest you if you're looking to have professional development hour credit for this. There will be a link in there where you can go to the clearinghouse and fill in your name to print out a certificate just to kind of serve as that proof that you attended the webinar. So I encourage you to do that. And also there will be a very short survey in there that we would appreciate you giving us your input. One of those questions will be important as we go forward in future years, because we always like to ask people that attend the webinars, what would you like to hear about? And we look at that every year when we get ready for the next year's webinar to see what's the topic at hand, what are people wanting to know about. So please do give us your input there. And then, as was mentioned at the beginning, in a few weeks we'll post the recording here today, which will have the video of the slides as well as all of the audio, and we'll be posting presentation files to go along with that. So please come back and give that a look. And as Karen mentioned, by that time we should also have that flyer to present in a very summarized fashion the things that she talked through about what is the state CMF list and how could it benefit your state. So I encourage you to go check that out when those are posted. So thank you very much for joining us, and we hope to see you back here next time.